Hey guys, okay, so now we're going to do this second set of notes. It's only one side, and again, I'm going to keep it to under 15 minutes because that's all I can do on this program. We're going to talk about naming acids and bases. Make sure you have your periodic table out for this one. I think you're going to want that for this. So we're talking about naming acids and bases. Get your notes out, and we'll start. Okay. Um, Writing names and formulas for acids and bases. So we're going to start with the acids. Like I said in the last set of notes, acids, their formulas, their chemical formulas generally begin with H. Okay, so their formulas are easy to recognize. And how we name it depends on everything after the H in the formula or the anion part. Hydrogen would be the cation, the positive, and the anion's what comes after it. So here you've got some common acids. Over here, don't think they're in your notes. You can always add on. But we talk about hydrochloric acid a lot. And we did talk about naming in the fall, but we didn't talk about acids. So before you probably would have called this like hydrogen chloride or something like that. So we're getting a little more in detail now. We're naming acids. If you have a formula that starts with H, it's an acid. So how do we name it? We care about what comes afterwards. But again, here's some examples: HCl, hydrochloric acid; HNO3, nitric acid; H2SO4. That's a pretty common one too, sulfuric acid. But you get the idea. Let's move on. Okay, so how do we name it? First of all, determine the name of the anion or what comes after the H. For example, we have HI, okay? So iodine is after the H, and we would say iodide, okay? H2SO3, I'm gonna look at the back of your periodic table to your polyatomics, and you can see that SO3 is sulfite, okay? And et cetera, et cetera. Cr2O7 over here is chromate, okay, or dichromate. The last three letters of the anion determine the rules you're going to use to name the acids. You will take the root of the acid's name from the anion it contains. And you guys are lucky, you get to use note cards on your test. You just have to know this or write it down, preferably memorize it, but you have to know this, okay? So if you don't, this is in your notes, this is a big deal, star it, okay? I'm going to refer to it a lot. You have three choices on how to name an acid depending on what comes after the H in the formula, okay? So if it's H followed by just an element, remember that's when we use that IDE ending, you would call it, you would start with the prefix hydro every time, and then you're just going to put the root in there. So your example was iodide, or for HI up here, we call that hydroiodic acid here, okay? If your what comes after your hydrogen ends with a ite, so like that second example, it was sulfite, ITE, we're going to change, we're not going to use the hydro prefix. We're just going to change the ending to OUS, okay? And this will make more sense in a minute. And last but not least, if your like polyatomic after the H ends with 8, ATE, no hydro prefix, and we're going to change the ending to IC. Okay, so let's practice that a little bit. So, okay, so HI, like I said before, is hydroiodic. We add that hydro prefix and that IC, is that called a suffix at the end? And then in the middle, you just put the root of the element. So this is hydroiodic acid for iodine. Okay. The second example, look at your notes. If the polyatomic ended in ite, SO3 is sulfite. We do not use the hydro prefix. And then we change the ending to from sulfite to sulfurous. And you might put sulfus, and I'd probably say it was okay because you get the idea. Okay, in this case, it'd be sulfurous acid. And our last example, if your polyatomic ends in ic, dichromic, we or I'm sorry, it ends in chromate, dichromate. Okay, it's chromate. We change the ending to ic, so dichromic acid. Okay, so it says no, the acid names do not contain the word hydrogen. Okay. So bases are easy, okay? Since many bases, or most bases that we're going to talk about, contain hydroxide ion. Hydroxide is OH. It's easy peasy. The only exception I already talked about in the last video was ammonia And you can write it in these notes if you want to. Ammonia is NH3, and that is a base. You just have to memorize it, okay? So bases are easy peasy. Ba is barium, okay? So an OH, barium hydroxide, sodium hydroxide, aluminum hydroxide, iron hydroxide, easy peasy on your bases. And there we go again, I just said that. One exception, just memorize that ammonia is NH3 and it's a base. All right, I know I went through that really fast because I think practicing is more helpful. You are going to get a worksheet when I'm done with this, so make sure you write these down so you have something to refer to. Okay, let's just practice writing the names for these acids and bases. First of all, is it an acid or a base? Remember, acids start with hydrogen, bases end with OH. If you see OH, you know it's a base, and they're easy. LiOH is just lithium hydroxide. Easy peasy. All right, H2SO4, it starts with H. I know it's going to be an acid, so I have to go back to my notes and look at those 3 rules depending on what it ends with. All right, I have SO4. Look on the back of your periodic table and find sulfate. I know it's sulfate, it's SO4. And my rules say that if it ends with 8, I change the ending. I'm going to just copy from your notes here to ic, okay? And then add acids. So this, if it's sulfate, instead of sulfate, I'm going to be sulfic, but it's actually sulfuric acid. And you just kind of have to practice to get the hang of it. So that's going to be sulfuric acid. Next up, MgOH. ICOH, is that an acid or a base? It's a base. Easy peasy. That's going to be, Mg is magnesium. OH is hydroxide. Okay. HNO2. Okay, we know it's an acid because it starts with H. NO2, I'm going to look on my periodic table, or I'm going to look on the back for my polyatomics. NO2, I believe, is nitrite. Okay, so if NO2 ends in ITE, you look at those 3 little things that I said to box on your notes, and we change the ending from ite to us, OUS, acid. If you don't know what I'm talking about, ask a friend, but it's in your notes that we just went over. Okay, so it was nitrite. I'm going to change it to nitrous. So it's nitrous acid. Okay, and like I said, just takes practice. Next, HBr. Okay, starts with H. It's an acid. So I know I'm going to have to look and see what comes after it. It's just the element bromine. That means it would originally end in bromide, IDE. All right, and when it is just H followed by just an element, we use that, that's the only time we use that hydro prefix, all right? And then we change it from bromide, we change the IDE ending, to IC. Oh, I got messed up there. Okay, so that would be hydrobromic acid, okay? Next up, I've got OH, easy peasy. I know it's a base. SR, I believe, is strontium, so strontium hydroxide. Okay, I'm just going to abbreviate this because I don't want to run out of time. Strontium hydroxide. Okay, easy peasy. We're doing the namings, but now we're going to go and do the opposite. I'm going to give you the name, and you're going to give me the formula. So here we go. Ammonia. I said, if you have to memorize one thing, just memorize that ammonia is NH3. Just know that, okay? I'm not going to give you any rules for that. Just know it, all right? Nitric acid, though, this follows the rules. I can kind of break it down, okay? I'm kind of going in reverse. Remember, I'm going to pause this real quick so I can write it. I wrote these at the top. Again, they're in your notes. We're going to be referring to them often. Okay, so I see nitric acid. Okay, I know it's an acid, and I see the IC, so I'm going to kind of go in reverse. Okay, this one ends in IC right here. Okay, so that told me that I know if it's ends in IC, but there's no, oh, I messed up. I'm incorrect. Rewind. Okay, it's IC down here. Okay, there's no hydro prefix, so I know that it has to be this third one at the bottom. So that nitric had to have been nitrate. Okay, just work with me here. So I know that my formula for nitrate is NO3, and I just know that if it's an acid, it starts with H. Okay, and then I still got to do my swap and drop. Okay, so hydrogen's +1. Look on the back of your periodic table, nitrate, NO3 is -1. So your formula is just that for nitric acid, HNO3. I know that's a lot, so let's practice some more. Okay, this next one, ooh, I see the hydro prefix. So I know this time I'm right. It is this one here, okay? If you see the hydro prefix, it's the first rule over here. And so again, I just work backward. I know I have hydrogen because all my acids start with hydrogen. I know it's the root is chloride or chlorine. Okay, chloride. Okay, so chlorine. And so I have the Cl for chlorine, and all I do is swap and drop to make sure I write the formula correctly. Hydrogen is a +1, no, chlorine is -1, so HCl. And we've talked about that one a lot in class. HCl is hydrochloric acid. Okay. Oh, I lost my little rules. Let me write them again. Again, just a few more. I know I'm going fast, so this video will be posted actually on YouTube, but also on my Google Classroom if you want to watch it again. Okay, naming acids and bases. So I've got calcium hydroxide. I know if it's hydroxide, it's a base. So just think about your components. Calcium, we know that, that's Ca, and it's got a +2 charge on the periodic table. All right, and then we know hydroxide is OH, and it's got a -1 charge. So when I swap and drop, bam, we don't count the ones. Your formula for calcium hydroxide, don't forget your parentheses, is Ca and then OH2 in parentheses. Okay, two more. Okay, we know it's an acid, so we know it's going to have hydrogen with a +1 charge. Chromic. Okay, there's no hydro prefix, so I know it can't be this, first, I'm going to label them 1, 2, and 3. We know it can't be number 1 because there's no hydro. It's not hydrochromic acid. So it's got to be this one, number 3 at the bottom that also ends in IC. All right? Which means it originally ended in ATE. Okay, you see that right here? So go backwards, chromic to chromate. Look on your back of your periodic table and find chromate. That is CrO4. Okay, find chromate. And it has got a -2 charge. So when I swap and drop, that's a +1 here. We don't have to do the 1, that doesn't count. The 2 goes here, so it's H2CrO4. Okay, and last but not least is chlorous acid. All right, how are we going to write the formula for that? Look at your 1, 2, and 3 up here. It can't be number 1 because there's no hydro prefix. Okay. There's no it's not hydrochlorous acid, so it can't be that. It ends in OUS, so okay, it's number 2. It's going to be the number 2 rule. Okay, if it ends in OUS, that means that originally the prefix was ite. So instead of chlorous, it was chlorite. Okay, again, look at the back of your periodic table, and you're going to find that chlorite is ClO2, and it's got a -1 charge. Let me just double check that. Yes. And then again, if it's acid, we know it always has a hydrogen to begin with a +1. +1, -1, swap and drop, they cancel out. So you're at HClO2. Okay. I know I went quick. I had to keep it under 15 minutes, but I think if you took all the notes and you read through them, you will get the idea. Just a reminder that these videos are on my Google Classroom, and that filled-in hard copies of the notes are on my website, my MISC website. You do have a quiz over this, naming acids and bases and just knowing about acids and bases, and that will be on Thursday, and you will get to use your notes, so make sure that you took good ones. All right, that's it, guys. Bye.